This was 8.1, rational functions. I'm just going to give you what the definition of a rational function is. You don't need to write it down. A rational function is a function who can be written as a fraction. So when you think about rational, we've been focusing on reducing rational functions and adding and subtracting rational functions. In the textbook, they want you to graph these rational functions. We're not going to do that in this class. We're just going to identify the important pieces to the graph. So what the graph would look like is a hyperbola. Here's more of what you're going to see in your homework today. We're going to ask you to find 4 things. We're going to ask you to identify the domain of the function, the vertical asymptote, horizontal asymptote, and if there's a hole in the graph. So I'm going to start off with just 2 of the items. So in these examples, we want you to identify the domain of the function, what can go into the function for x, and then what is the vertical asymptote. So we look at the domain and the vertical asymptote together, and we only need to focus on the denominator. So remember when we were in section 8.2 and we asked you after you factored it and we looked at that denominator and said what would make that undefined, what is the domain restriction? So in this function, if I substitute a 9 into that function, that denominator is 0, which makes it undefined. So that is a restriction on its domain for x. So how we write the domain for this, it's all real numbers except x cannot be that 9. So that if we were to go out and graph this, there's a vertical imaginary line at x equals 9. So let's try another one. The function is f of x equals 2x cubed minus 5 over x squared. It is already factored out, and we want to look at the denominator. What would make that denominator undefined? What would I substitute in? What would be the domain restriction? Well, if I substitute 0 into that function, 0 times 0 is 0. That makes it undefined. So that is my domain restriction. So every number in the x system, x values, negative and positives, would work except for 0. So how you write the domain is it's all real numbers except x can't be 0. So then you would have a vertical asymptote at that place of 0. So you're going to have an imaginary dotted line at x equals 0, so that means the graph couldn't go through it. Last one of these, question C. We have a function, and the function's denominator is already factored. And we want to find the domain restrictions first. So see if you can find out what are the domain restrictions for this polynomial. For x minus 5, x plus 1. You should have gotten, if I substitute a 5 in there, that makes that parentheses a 0, that makes it undefined. Or negative 1. So the domain then is all reals. We're going to shorten it up. That's the notation we use in math. Except x can't be now 2 numbers, 5 or negative 1. So now we have 2 vertical asymptotes at x equals 5 and x equals negative 1. When we move to pre-calculus next year, we're going to take the time and graph these. All right, the next slide. I do want you to write this entire box down. To find the horizontal asymptote, for short, just call it HA. Look at the degree of the numerator. Remember, the numerator is the top of the fraction, and the degree of the denominator, which is the bottom of the fraction. There's 3 different scenarios. The first scenario is if the degree of the numerator is smaller than the degree of the denominator. Then you would have a line horizontal line at y equals 0. That y kind of got cut off there. If the degree of the numerator and the degree of the denominator are equal, then what you have to do is you have to divide their leading coefficients. The last one is if the degree of the numerator is greater than the degree of the denominator. Then there is no horizontal asymptote for this problem. So I'll give you a little bit of time to finish writing that up. And then I have a couple examples for us to do. So the first example, we're just going to focus on the horizontal asymptote. We're not going to go back and talk about the domain or the vertical asymptote. So we give you this function, f of x equals 1 over x minus 1. We want to look at the degrees of the numerator and the degree of the denominator. So this is my numerator, and its degree is 0. There isn't even an x variable there. So the degree is 0. The degree of the denominator is 1. The reason why is that x is to the 1 power. So now we have to look in our chart above in that box. Is our degree of the numerator less, equal to, or greater than? Well, it is the first one in the blue. The degree of the numerator is smaller than the degree of the denominator. 0 is smaller than 1. So we are going to use this situation. I kind of just wrote out the information. So we have a horizontal asymptote at y equals 0. Let's try one more. Example B. The function is f of x equals 2x squared over x squared minus 1. And we're just finding the horizontal asymptote if it exists. So let's identify the degrees. So the degree of the numerator. The degree of the numerator is an x squared term, so the degree is 2. The degree of the denominator is also 2. So we have a scenario where both the degree of the numerator and the degree of the denominator are equal. So now let's go up to our chart. The chart says in the red that if we have the degree of the numerator equaling the degree of the denominator, then we divide by their leading coefficients. So the coefficient of the numerator is 2. The coefficient of the denominator is 1. So what we do is we divide 2 by 1. So our answer then is 2 over 1, so y equals 2. I'll give you a little bit of time to finish writing that out.